In this video, we'll explore the data analysis. And the best part is that you don't need any advanced maths or statistics. I won't be diving into the formulas. Instead, we will focus on the practical applications of these concepts in the real world scenarios. First, I will explain everything, then we need to dive into the real world scenarios. Understanding the data, first thing you need to understand in data is very important. Can be two types like categorical and numerical. The numerical data I show in the screen. The numerical data can contains into the two like continuous variables and discrete variables. The continuous variables is uncountable or unpredictable values. For example, temperature or wind speed continuously changes. It cannot be preciously predicted all the time. Discrete data, this is type of the consist specifies countable values like such as a weekly, monthly or yearly data. And the next thing is categorical data. The categorical data contains only specified set of represent set of possible continuous values like this is represent set of values or the categories, right? Instance example, gender can be classified as a male and female or combine the both of them. Integers, like you can combine the integers like numerical values and categorical values. You need to understand them. And the binary is one of the format like a zeros or ones or true or false. And other one is ordinal. Knowing the data is very important and crucial. Processing the statistic information, which is often involves the procedures like charting and filtering. Data structures, next one is data structure. Data structure into the two forms like rectangular data and non-rectangular data. Most of the data scientists works or data scientists or data analysts works with the data rectangular data. It's cannot be a rectangular data. It can be transformed to rectangular data from format and facilitate analysis. Rectangular data with the two-dimensional origins originally like into the rows and columns, and another one like it's a means it was a structured data, and non-rectangular data means it's a unstructured data. It's mainly used like fully machine learning like examples it's images, videos, text documents. These are the both we have to use like most of the time like CNNs and artificial intelligence we have used the non-rectangular data and some machine learning models for the predicting the images like for decision trees. Now let's discuss some fundamental statistics. Measuring starting with the mean or average. The formula for a calculating the mean is straightforward. In the practical term, the mean is help to understand the central tendency of a data sets. They provide a single value, the summarize and group of numbers. I show the example. In this example, if you run a small bakery and you want to analyze your daily sales over the past week to understand your average income. Here your sales for each day as Monday has 150 rupees and Tuesday 200 and Wednesday 250 and so on. Then they calculated some of the sales, some of them all, and then next thing calculate the number of days, and they calculate like a total number of by the number of days. We get the mean like is a mean value is 300 rupees. You can either you use np dot mean, it automatically calculate them. You don't know the formula, you don't know the formula. This means your average daily sales for the week is 300. This mean is a powerful tool in data analyst or data scientist. This helps to help you make informed decisions based on the historical data, like whether you are assigning the sales, the customer feedbacks, or productive levels, and the calculator means provides the valuable insights in your business performance. And the next is weighted mean. The weighted mean is incredibly useful when different values in a data sets holds varying levels of importance. Like mean is not like that. Likely a simple mean it's calculating the average, but which treats every value is equal is a mean. But a weighted mean allows to use give us to influence more influence to certain values based on the significance, like a significance. Imagine you have the financial, like showing the example. Imagine that you have the financial portfolio with the different investments, each with the different values and return rates. Like I invested in 1,000 some share and 5,000 and 15,000 on the dollars on the some shares, and I got interest rates return rates is 8%, and 5,000 is a 6%, and 10,000 is 10%. Then calculated the weighted mean sum of the interest rates and multiplying like 1,000 into 8 and weighted sums, 5,000 into 6 and 15,000 into 10. This is a weighted sum. These are the weighted values. Like in the statistical terms, we call this is a weighted values. 8 is a weighted and 6 is a weighted. The investment values into the weighted values. So multiplying the weighted values, then we got the weighted sums. And weighted means weighted sum by total number of total investments. Like we got the 8.66 interest rate, and we can also use the nb dot average. So want to find the average rate entire portfolio, but also consider a amount you are returning each. This approach gives the more accurate pictures of the total portfolio preferences, as reflected how much you are invest on the each asset. Weighted means are commonly used in the financial sectors, surveys, and quality assignments, where not all data points are carry the same significance. That's why uh, enabling the more precious insight analysis. This is one of the most important. But low cases we are using. Next is the median. Median is a center value. Like this is a total scores. In this example, we take the total scores of the students. One is outliers, but what was the median? Medians, I explained the one thing. The mean is affected by the outliers. We discussed what was the outliers and the uh, has going on, and mean is affected by the outliers. This is one thing. There is a huge gap, the 100 and 150. This is outlier. Which we discuss this later. But median is not affected any outliers, anything. Like I got the median value is in this using the NP. I got the median value is 90. Most of the 90% of the median is like 50% of the data. Is take the 50%, like 50% of the data was below the 90%. The taking the this is the median. Next, the percentile. A percentile tells where the particular value stands in the datasets. Shows the percentage of the value or given below the points. Example, given these are the values. Like and imagine a school test, 1,000 students. If you are students are scoring 75%, like it means scored 75% of the other students, so higher the percentile. This is a better comparison. Like I explained the this is an example. In this course, you need to percentile or the quartile. The data must be in short order, like ascending order. Smallest ones are the downs and highest ones are the ending, like shortest by the ascending order. The percentile I want to score at the 25%. 25% of the data like 25%. I got the 25%, it's 70. Under the 75%, 70%, 25% of the people are under the 70%, and after the 50%, I got the 50%. 50% means 80% uh, the people are below scored 80%. Then 75 means 75% of the less than peoples are scored below the 90s, and 90% or 90% below the 90% means 97.4. 90% of the peoples below score the 97.4. This quartile is not like that. The quartile is split the data into three parts, not the four parts. 25, 50, and 75. These are the same. The both is not difference. Next, the percentile. A percentile tells where the particular value stands in the datasets. Shows the percentile of the value or given below the points. Example, given these are the values. Like and imagine in the school test, 1,000 students. If your students are scoring 75%, like it means scored 75% of the other students, so higher the percentile. This is a better comparison. I explain the example. This is an example. In this course, you need to percentile or the quartile. The data must be in short order, like ascending order. Smallest ones are the downs, and highest ones are the ending, like shortest by the ascending order. The percentile I want to score at the 25%. 25% of the data, 25%. I got the 25%. It's 70. Under the 75%, 70%, 25% of the people are under the 70%, and after the 50%, I got the 50%. 50% means 80% the people are below scored 80%. Then 75 means 75% of the less than peoples are scored below the 90s, and 90% or 90% below the 90% means 97.4. 90% of the peoples below score the 97.4. This quartile is not like that. The quartile is split the data into three parts, not the four parts. 25, 50, and 75. These are the same. The both is not difference. The robust statistics. Robust statistics are statically methods that's not heavily influenced by the outliers or extreme values. Unlikely traditional methods, robust methods aim to provide readable result even when they are data is anomalies. This is especially used in the real world datasets, which is often contains an errors or extreme values that can be skew the results. This robust statistics is very helpful in the real world cleaning processes. Like first remove the outliers and some of the things. Let me discuss one by one. Let's Trimmed mean. Trimmed mean is a commonly used robust statistics. Instead of calculating the mean of all values, trimmed means ignore the percentiles of highest and lower values. Uh, Raw value reducing the impact of outliers. For example, if the 10% of removed means would be ignore the lower 10% and higher 10% of the data point, the calculating the mean of the remaining values. This is provide the more readable average of the datasets and extreme values. For example, there is a significant gap between the data, hundreds and thousand, indicating the presence of outliers. They skew the mean. In this constraint, the median is not affected uh, by these terms of extreme values. The addressing issue. I want to use the remote mean by the removing the first 10% of the data. So remote mean is very useful when you want to mitigate the effect of the outliers. Then I used 0.1 means 10%. It's uh, it's still influenced by the outliers. Then I use the 20% of the mean, 20%. Okay, it's remove the both 20% of the data and give the perfect mean. This is very helpful. Why in the real time scenarios you don't know what was the data, like some. Yes, I discussed this as outlier. What was the outlier? Outliers means extreme values. Uh, this is I show you this. This is a very affected by the outliers. Like this is all the one pattern like 10, 20, 13, 14, 14. Before the there is no significant gap. The like 5 or 6 or so. This is a, but there is a 70 70 like 70 points of the gap between the hundreds, 30 and 1000 hundreds. uh, that's why it's considered as outlier. 100 is an outlier. We have to use the bunch of the tricks to remove the trim would mean one of the trick, and these are the tricks like z score. We discussed the letter and iqr interquartile range. This is also used with a bunch of the useful options. We have to discuss the letter, remove the outliers. Remember the one thing, we hear the outliers, we deal the outliers the most of the times in the real data. uh, we remove them, we do some like do some statistics tricks to combine to remove or change these outliers. Next, the deviation refers to the difference between the each individual value data points and the mean, like average, mean average of the data sets. It tells us the how far each value is from the average value. Why we use the deviation? Understanding the deviation help to identify the distribution of the data sets, the points relative to the mean. It can be highly highlights the patterns of outliers and the various within the data sets, which is crucial for the many statistical analysis and decision making process. Like I show in the example, can I run it again? This is show there is a positive values and negative values. The negative values deviations indicates the values below the mean, while positive values indicates the values above the mean. This is insights help to understand the spread of the data sets and identify where is the most values lies in the relations to the average. Next is a variance. Variance is a statistics measurement that indicates how far each number in a data sets from the mean, and thus from every other numbers in the set is measured the spread for the disappears. This present of the data set. Why we use the variance? Variance is to help to understand the variability of the data sets. It's help to assigning the risks of predictions outcomes, making comparison between the different data sets, and the high variances indicates the great spread values, while low variances indicates the closer to the mean. This is the one thing I show the example. Import numpy, given the data sets, the mean, the square root deviation, and the sample variances. So population variances. I talk about in the sample variances. The 4.333 means it's a very low, means uh, it shows the while the values are generally clustered around the mean, there is no notable the spread that can be important analysis of the decision making. Like a deviation helps us how see the individual data points are related to the mean, providing insights of variability and outliers. Variances are quantifies the variability allow from the deeper the analysis of the comparison between the data sets, such as the crucial of the many fields like such as financial engineering and social services, like social science. Standard deviation is the square root of variance, like a square root of variance. We use the standard deviation most of the times finding the value. I show you this. um, the variance standard deviation, like I show you this is I plotted it, the df dot goal, the use some plot. This is one thing. The red line indicates one standard deviation. There is a most of the data lies between the one standard deviation. I show you this is red line indicates one standard deviation. Most of the sometimes we're working with the data analyst, the part of a data scientist team, the statistics analysis. Statisticians recommended you one or two standard deviation that's make you for the future predictions or decisions based on the values. Understanding the standard deviation is helpful because it allows to quantifies how much the variations exist within that sets using one standard deviation. Like I show in the example, z is one standard deviation and typically capturing about 68% of the data, while two standard deviations or green yellow lines capturing approximately 90%, 95% of the data. This helps to assigning the reliability for the data, making informed predictions. The most of the times we this is a bell-shaped curve. Most of the times this is is also called as a normal distribution. The another example, this plot is very helpful. Following this plot is very useful to identify the outliers. In this data you can see there's most of the data lies between -2 and the positive 10. After the 20 the few points such as a 30 or 40 and 41, sorry, 39 and 40, this is the considered outliers. These outliers can be significant affected the mean. Other significant measurements and affected the mean, and other statistical measures. Statistical statisticians use the various techniques that handle the outliers, such as multiplying or subtracting the values to minimize their impact. This approach is helpful or clean the data and improve the accuracy for of our statistical analysis by removing or adjust the extreme values. Next, the mean absolute deviation. The mean absolute deviation is one of the trick, uh, like uh, like data points are very close to the mean or not. If the mean absolute deviation is a value is low or it's very small, it indicates the data points are very close to the mean. This suggestions the values of the data sets entire nearly same to the exactly the same. But you can't believe the blindly is a mad. Sometimes it works, sometimes it's not. That's why you go with the standard deviation, and the median is also same. Like a median is median absolute deviation called as MODA. It's a statistics measure. And the statistically measure the quantified disappear of the data points around the mean. This mode is values appears like most frequent data sets. So where mode is more representative means central tendency means like uh, we less to use, but both are used in statistical measurements of the categorical variables. Range is basically measure the variability that shows the difference between the large and smaller values in the dataset. It gives an idea of the spread or the dispersion of the data, but doesn't provide insights into how individual points are distributed with the range. Note these are the most important things, sensitive to the outliers. Range of only consider the maximum and minimum values, so a single outlier can greatly increases the range, potentially giving a mislead the sensitive of the variability. Lack of details lack of details, the range does not show the data point distributed with it. Others, the measures like the variance and standard deviation provide the more details about the data distribution. Order statistics means nothing. It's just ascending order, shortest to higher, like lower to higher. Some cases we use like interquartile range. We use like percentile. We need to sort their data and then find the values like a 25 percentile, 35 percentile. That's why you use the order statistics. And next, interquartile range. The interquartile range is a measure of the statistic dispersion. They represent the range within the center of the 50% of the valuable datasets. Like it is especially useful the datasets with the outliers. Sometimes as it's focused on the middle spread of the values, making it more resistance to extreme values of the comparison to others, like measure like ranges. Like robust against the outliers, but we focus on the middle 50% of the data. Like IQR ignores the extreme values, making its idea for the datasets may have the outliers insights into the variability. IQR shows the spread. The portion of the data helps to understanding the data typically, using like IQR is fundamentally creating the most of the times we use the IQR as a box plots the data analysis. Then we find this finding easy way to find the outliers. It's data is sorting by the Q3 minus Q1, the Q3 minus Q1, the 3.0. Oh, that's why 0 0. Okay, the 3.0 data only gives these values, and outliers will be indicated like easily. The bias and variances, biases and bias estimation. Like unbiased estimation n minus 1 we discuss about the next the degree of freedom. Bias estimation means systematic errors. We calculate the bias uh, while the model is fit or overfit or unfit. In machine learning models, after trying the models we need to analyze this model is overfitted or underfitted, or is model is working very well. Next, the plots. This is a historical of the symmetric data. Most of the times it deals with this data in whatever the data we need to convert into this binomial distribution. There's a bunch of the names this like binomial distribution. Sometimes we call, sometimes some people calls as a normal distribution. Some people calls as a bell-shaped distribution. Some people calls as symmetric distribution. There's a the use names, but the value is like this. It's symmetric, like bell-shaped curve. There is a next we have the discuss of the skew distribution. There are the two types of skews, like positive skews, rightly skewed, and negative skews. Negative skews means left skewed. In this positive skews distribution, bulk of the data points are concentrated for the left side with a long tail, extremely extreme to the right. Here, this is the one thing. This is positive skewed. Basically, these values are this. We need and negative skewed data. Negative skewed means this negative skewed, the bulk of the data points are concentrated to the right side with the long tail extent for the left. This is the negative skewed. So the both of the these values like mean and median, sorry, mean are very infected, influenced by the long tails for the higher values or the lower values. Sure. This is a bunch of the tricks here. The I show you the basic tricks, the handling the positive skewed data and negative skewed data. First, we discuss about the positive skewed data. These are the three main basics, log transformation and square root transformation and box plot transformation. Log transformation. This is typically first approach. Uh, it does not yield the desired results. Right. So the next time I show you this in the plot. So and this is still hues the flaw. This is still transform, like still skewed on the right side. Then next, then try the next transformation. The square root transformation. This is applied for the log transformation, but does not fully normalized, but still the skew, but it's It's better than log transformation. Then try with the box scope transformation. This transformation, uh, this transformation is particularly useful handling the skewed data. Is often effective with the normalized it and very useful. Then I want to pick this. Let's try this. So jet box transformation. This still use. This is not also very work well. This box transformation is very well for this data. We need to try this all of the things. We have the data, then pick the one. What was the score very well. The next, native skew data. There is a native skew data. There are three most used transformations, like basic use transformation, like box code transformation, yo JSON transformation, and jet code transformation. Box code transformation use the both and positive and negative. I try the box code transformation. It's not very well. Uh, and Z code. This is a Z score. There's still a huge skewed the left side. He's still influenced by the next. Then the power, like Jetson transformation is very well. It's uh, this is still skewed, but use some trick like a trimmed mean and IQR. Some tricks. I discussed this on the real time scenarios how this is works. Right now, this will measurement to find the outliers. Much of the rare cases we use in the finding the outliers. It's equal to 3 means the shape of the distribution is a normal distribution. Greater than 3, it indicates heavily tiled, a sharp peak, but then a normal distribution. Uh, it's often have the outliers. Less than 3 indicates the distribution have the lighter tile and the flatter peak, the normal distribution. The kurtosis, this is a kurtosis 0.1731. That's fine. Showing the example is less than 3 means lightly tiled and fatal peak. The print is normal. So this is a greater than. So it's a greater than the. That's why it's a heavily tiled and sharp peak. But then a normal distribution. But for the we use the rare cases. In the box plot is based on the IQR. I show you the interquartile range. It's easily find the outliers. You can easily find the box plot. The box plot helps you that easily find the outliers. And then next, density plot is visually distribution the content values. It's like a it's very useful, like a colorful distribution. You can explain anything, like it's a normal something's outliers, uh, whatever it is. You can easily explain the people's the team how this the data is look like. Probability is a likelihood of an event occurs. For example, we can probability to predict the chance of the rain based on the observed pattern. This process is involved the analysis past data inform the future outcomes, such as it determines how likely it's to train on the particular day. The probability also the play the key role in the machine learning. It's helped to agents like current data and make the prediction about the future events. Plannings and predictions or assigning the aspects of the machine learning or derived by probability models. We will discuss this more in this later in this video. Next one is misleading graphs. The misleading interpretation of the data can often rise uh, like a selective readings or presenting of the information. This is particularly dangerous in the marketing where data can be manipulated the presence of the bias view of reality. For example, I show in this consider this week data shows values are the 50 and 52 and 49 and so on. While these numbers are appears the significant difference, the first glance, the actual gap between this quite very small, like just 1 and 2. At the bar chart, these are slightly difference can be aggressive visualization. leading to viewers believe there is a substantial difference where there is no. There is a first is graph like the this is a regular graph. You can view this is okay. This is a perfect one. Like the other one is a misleading graph. In the crucial of the interpretation day, the careful, the crucial of interpreted data, the careful for the avoiding misleading reputations. This proper data visualization and interpretation are virtual to ensure the consumes the draw from the data accurately reflected to underlying the reality. Is a statistical method measure the direction and strength relation between the two variables. Understanding the correlation is useful for analysis, analyzing the data and create a great aid futures analyzing the machine learn predictions. For example, positive correlation means where both variables are increase or decrease together. A classical example relation between the height and weight. As height increases, weight tends to increases as well. Con- the next is the negative correlation when occurs the variables increases while other one decreases. An example, the relation between the speed and time taken. As speed increases, time taken covered fixed distance decreases. In cases there may be no correlation between them. Means there is no consistent patterns between these variables. Recognizing the correlation can provide the variability inside the prediction models and decision making. I show in this example, they show in this showing using the magic plot. We discuss this later how this plot works. All the ones means all are positively correlated with each other. And the next Pearson correlation is also known as a Pearson product moment correlation coefficient, like PMCC, is a statistical measure to assess the strength and the direction of the linear relationship between the two consistent variables, two continuous variables. It's widely used statistic to quantify the closest two variables movement in the relation moves in relation to each other. Suppose to investigation relation between the hours of the studies student studied and exam score. Student, you can collect the how many hours each student and their corresponding the exam score by calculating the Pearson correlation coefficient, indicating the strong positive. Like I got the R value is 0.85. This strong positive correlation means suggestion that study hours increases, exam scores also tends increases. Limitations is this not works with the non-linear data. uh, like if sensitive outliers, if there isn't sensitive outliers, the Pearson correlations is sensitive extreme values like outlier if you are using the outlier. And the Speedman correlation. The Speedman correlation, one of the most useful, is known as a spaceman's rank correlation coefficient. Most of the times we use this in machine learning to find the relationship between the two values for the better two predictions and how non parametric measurements, like it's non parametric. This assigns the strength of the direction association between the two ranked variables. It's particularly used to analyze the ordinal data where assumes the person correlation such as the linearity and normality are not at. Example, suppose we want to relationship between the students and ranking in mathematics and science. You collect the data and the both subjects and calculations. Speedman correlation coefficient. If I find is R and S is equal to 0.90. This indicates a strong positive correlation suggestions. The students who ranked high in the mathematics also 10 rank in science. Advantages, like Spearman advantages, if Spearman correlation does not assume the normal distribution for the ordinal data. Robust outliers because the lens ranks the raw values. Spearman correlation less affected by the outliers. And the other thing use them where we use them. Like patient correlations use the financial, healthcare, and social services, uh, and the between this income, like in the financial, between relationship between the stock and product prices, and healthcare investment in the doses of the doses of medication and patient recovery, and social services like income and education level. And Spearman correlation is used like a uh, marketing evaluation, customer satisfaction of the ranking against the product sales, education analysis, uh, relationship between the students and different subjects, behavior studies like correlation between the surveys and ranking over the attributes. This is the most important. These three, like we want to predict a model. First, we need to find the is there any relationship between them. Then we test it, and then we select the value, when we select which model is a perfect, like is a linear regression lasso, or another one. The next is heat map. Heat map is one of the best visualization how the values are correlated the heat maps, in this heat map I shown the example. In this heat map, A, the both are correlated is the one, is the both are exactly correlated, this is the one, the perfect. And the B and A is a 0.11 is a positive correlated, and C also 0.076 is a very positive correlated, and D is negative correlated, minus 0.06. D and A. So, and like all of this. And the next, we have the contiguous tables and exobinding and counterplots and wiring plots. These are the rarely uses, but we have the two variables, like two continuous variables, or two continuous or two numerical variables. We want to find them, relationship between them using the plots. These are the most useful plots, the exobinding and counter plot and violin plots. Understanding the data, visualizing the plots, it's very useful. uh, while the data how it's spreaded, how these variables are, like the violin plots indicates the how data is spreaded, like A and B.
Or a data analyst, data qualities often matter more than data quality. Higher quality data is essentially for accurate models, including like a factor like a completeness of the consistence, accuracy, and proper formatting of the data points, priority data quality over the like lead to better insight, the more reliability outcomes. I shown the example. Uh, this is the example. This is a picture is denoted as the population. We most of the times in the data analyst or the like whatever it is, you are a data scientist or data analyst, we not deal with the entire population. We pick up some samples and test and clean the samples and analyze the samples, and these samples we test on the population, how this is affected, how this is not affected. Then the samples, a sample is a smaller repetition portion of a population. Is often we use like a statistics to make the process more manageable while dealing with the loss data. And means then the population size, we had how many, like symbolized and symbolized the total size, for like example we might takes 10% or 20% or 30% of the population size. Like this is a and means how much you take the population, like 20 or 30 or 40, 50, 70% of the data or 90% of the data. And random sampling, it involves like a select the subsets for the population, like ensuring each data point has a equal chance of the selections. Like a stratified sampling is one of the uh, trick, but we not use the stratified sampling the most cases, but random sampling we use the most of the times. We As shown in the example, this is the randomly select some every like I show the example. These are the different type of the peoples. I selected randomly each type of the people. This is a sample, this is a random sample. It's very useful. Like most of the times we deals with random samples, not stratified samples. Stratified samples are not useful. Like it takes sometimes entire these data or entire one person, like one particular line of the data. It's not very useful. So this go with random data. And the next, biases. Biases is statically refers to systematic errors, the cause of the deviated turns of the values. Like shown the example, these are the biases. This determine the model to fit. We check the biases, bias levels. High bias means low variance. High bias and low variance indicates the underfitting, and which is low bias and high variance means such is the overfitting. This idea is balance the good fit occurs when both bias or variance are minimized. We, we use the biases like use cases like how the model works in the machine learning. Uh, Next, size versus when does sample size is a significant impact result. Like while data is big data is often provides the deep insight, sometimes the smaller was chosen, the smaller size is more efficient. A smaller data set can be reduced the bias. Import data exploitation, like and help to identify the data issues like missing values or outliers and more feasible. For example, handling the thousands of the records and addressing missing values detect the outliers is often more manageable than working with the millions of the records. Sample means versus population means sample means the population means divided by mu. It's the average of all data sets of the population. It's a mean entire population. Like this is the population, we take the entire population of the mean, and the sample mean it's denoted by the x bar. We take the x bar. This is like a sample mean. And then next, hypothesis. I already discussed this null hypothesis in the previous. Null hypothesis means nothing. We take some the sorry yeah, for the to clarify the null hypothesis statistical term, use the hypothesis testing. It refers to deflect the positive, there is no effect or no different. There is a condition hypothesis testing evidence, like it's a strong evidence. We use the statistical evidence to prove the peoples who are uh, if you want to prove this is working or not, use the null hypothesis or alternate hypothesis uh, uh, to convey the your supervisor or a statistician its model is working or not. This is no my fault, this is working or not, something is going wrong on the other side. This is a population mean and the sample mean example using the NPR channel. In data spoofing, the data spoofing is a practice in data analysis where the research and search for the patterns in the data without predicting the hypothesis. This approach can be lead the misleading the results as a part of the patterns. Maybe the random gathering reflect the genius underlying the trends. Data smoothing often occurs when the analytics essentially explore the test different hypotheses which the same data sets hoping to find the statistical significant result. However, any pattern the purely by chancing can be mistakenly interpreted by the meanings. Example, data smoothing suggests the research analysis hundreds of the stock markets indicates to find the predict future the stock prices. If there is no clear hypothesis is set up beforehand. Next is a vast search. The vast search is a like vast search effect, or a multi-testing problems occurs the vast search a large number of hypotheses that explore the many variables which is tested without specifying the prior hypothesis. Due to this number of tests, some statistical significant results may appear by chances along the rather reflects the true patterns. Regressive to the mean next. This is random. This is one of the example of the significant. Next, regressive to the mean. Regressive means statistical phenomena that occurs when extreme values data sets, either via the high or the low, or tends to the move the closer to the mean, which is measured to again. It's very useful in analysis that tends over the times, but often settles around the help to avoid the incorrect conclusion between the particular intendants. And the regressive to the median is similar, but with a focus on the values, the moving the closer to the median, so rather the mean. This is less common, but may be relevant. What the median rather the mean is a better represent the central tendency, especially the huge data sets. We be careful with the regressive to the mean, regressive to the median. Sometimes it's going to be the show errors. And the next is central limit theorem. Central limit theorem is a fundamental concept of the statistics that explore how the sample size increases. The distribution in the sample mean approach the normal shape. This distribution regardless the original data distribution. Example. The showing the example, we have the sample size is at 10. The data is widely spread, showing the lots of variability. As the sample size to 30, the the spread of the sample means being decreases, maybe distribution less of the variability, and the 50, the sample mean becomes the less spread out, and the 70, the distribution started forming the clear and more bell-shaped curve. Finally, with 90 samples, the distribution of the sample means closer to the resembles to the perfect bell-shaped, including a normal distribution. The CLT is especially useful for the data scientists and ability analytics to make inference about the population parameters for a sample data, even when underlying the distribution is unknown. This is why data scientists often really of the large samples to achieve the really normal distribution. The population standard deviation. The population standard deviation measures the spread of the set of the values of the entire population. Like a, it spreads the data entire the population, and the sample standard deviation estimates like a standard deviation of the sample data. Standard errors is very useful, helps to understand how well the sample mean estimated the population mean. This is examples like a population and standard errors. Bootstrapping as a statistic resampling technique used to estimate the distribution of a statistics like the mean and variance and confidence intervals by the repeated sampling by replacing the observed in the data. Here the here this is an example. You better to understand. It's a huge video. This link you will easily understand how the bootstrap works. Resampling takes of random resampling works. Better to view this video. Like estimation the mean and the confidence interval. Suppose you have the small sample of test score. You want to group of students. You want to estimate the mean score of the confidence. 95% of the confidence. Use the bootstrap. You can randomly samples with replacing original from and for originally data points so the many times like example 1,000 times, calculate the mean of the each resampling data sets and then use the mean to determine the overall means and the confidence interval of the popular mean. This approach is provide the more accurate representation like uncertainty comparison to relying of the original sample means. And the resampling is another. The resampling for the example, resampling is another statistical technique used to repeative draw samples like a data sets, perform the analysis of the samples as economies. Sorry, it's a method It's a method like bootstrapping, cross validation, and the primitive tests. Why we use the resampling? Resampling allows to assume the variability of stability of a statistics like the mean and median regression coefficient according to different samples, provide the insight into how the statistic might changes the different data. Um, like example with the cross validation in the machine learning, the k-fold the cross validation it's involved. We discussed this the k-fold cross validation in the later. Split the data into train the model like a k-mention subset. This data is this stat sorry this testing it is one of the remaining subset. This process is repeated k times and they provide the comprehensive assessments of the model performance. The bootstrapping for the that estimate the suppose you have the small data sets repeat customer purchase amounts. Using the bootstrap you can repeatedly samples for the data set estimate the mean purchase amount confidence intervals. The resampling technique is ensure the ability to make inference for the data and validation models and they estimate the uncertainty all while providing the flexible and robust and a statistical analysis. This is a uh, this is one example. It's provided by ChatGPT. Ask the ChatGPT, then it's make a example for easy to understand how this is works. So lower boundary, upper boundary, 94%. The resampling versus the confidence interval. The confidence interval is the range of validation determined for the sample statistic. This is like a continuous truly population parameters provide the estimation range of values that is beliefs that encompass the parameters of the intervals like 95% of the population with certainty level of confidence like commonly used 95% and or 99 where this is one of the trick like this next we have the errors absolute error square root errors mean absolute errors the mean square root errors root mean square root errors. These are the most times we use in the machine learning how this is models predicting well or not. If these if you use this these values are get the low this the model is predicting very well it's high it's not predicting well. We discuss the later on the next videos using the machine learning. The next standardization standardization is on the technique we use like a uh, it's converts into the like the original data I show in the example it's original data 10 20 30 40 50 but the mean is 30 using the standardization I converting the values these 10s 20 30s into the zeros to 1 like 0 and 1 the values between like 0 1.2 0 1.3 1.4 like this. This is a easy way I shown this is one of the easy way if data is like huge you need to convert zeros and ones it's easy way to train the model machine learning model but be careful sometimes it's not useful very well. Be standardization when you the output like when the predicting the models somewhere is deployed